Hello everyone, welcome to UpSmart IAS classes. This is your Reddy Prakash. In the previous class, we have studied everything about what is matter, how the matter is classified into various other things and various other information regarding everything about matter, so that whatever a question is asked from matter topic can be easily answered in the examination. So the matter as a chapter is completed. Now we'll quickly get into the second chapter, that is the acids, bases and the salts. Okay, acids, bases and the salts. So in the first chapter we studied everything about the matter, and now we are going into classification of matter, that is acid, bases and the salts. So jumping in quickly, let me tell you what acids, bases and the salts mean by. Let me take a whiteboard so that I can explain more clearly. So, do you know the difference between acids and bases and the salts? If you know, kindly comment it down. So, three things: acids, the base or bases, second one, third one is the salts. Third one is the salts. So what do you mean by acids, bases and the salts? So I'll first give you the example of acids, bases and the salts, so that you will get it, you will get the concept more easily. One of them being hydrochloric acid, HCl. Bases, the major base being sodium hydroxide, NaOH, sodium hydroxide. Salt, we can consider the table salt or the common salt itself, that is NaCl. So acids, bases and the salts. So HCl, hydrochloric acid, sodium hydroxide, sodium chloride, that is the common salt. So why acids, bases and salts? What is the meaning? See, if you dissolve this, if you mix the hydrochloric acid HCl in water, it separates as H plus Cl minus. These two elements will be obtained. Here it separates into H plus and Cl minus, hydrogen ion, chlorine ion. Similarly, if you separate NaOH in water, what you get is Na plus, in addition to it OH minus, Na plus and OH minus. This is what you get when you dissolve a base in water. Now see. Now you got a Na plus and a Cl minus. If you mix both acids plus base, acids plus base, what happens when you mix an acid and base? Example, hydrochloric and NaCl, what happens in that case is the H and OH, these two will get on to become water. These two will go on to become NaCl. Understood the examples? Acids means hydrochloric acid. When you dissolve an acid in water, it separates into hydrogen ion, chlorine ion. When you dissolve a base in water, it separates into sodium ion and OH minus. Okay, OH minus. And when you mix an acid and base, what you get is a salt, NaCl. This is the examples. Now, then what is the definition, sir? What is the definition, sir? The definition is, when a substance is dissolved in water, if it releases hydrogen ion, if it releases hydrogen cation H+, when it releases H+, it implies that substance is a acid. When it is dissolved in water, if it releases H+, then it is called as acid. Similarly, when it releases hydroxyl OH-, then the substance is called as basic. Basic or base. The substance is called as base. Okay. And this theory, this discovery was given by Arrhenius. This theory was given by Arrhenius. This theory, when H+ is released, it is called as acid. When OH- is released, it is called as base. This as an observation was done and the theory was put forward by Arrhenius. Understood? Easy. What is the definition of acid and base? We can take an example. We can see how that example reacts with water, and if it releases H+, it is called as acid. If it releases OH-, it is called as basic. If both acid and basic meet each other, and what it produces is called as salt, and this observation was done by Arrhenius. Easy. And along with this, there is one more thing. Basic or a base releases OH-, or it can also accept H+. It has an ability to accept H+ from acid. If it has an ability to accept H+, then also it is called as base. And this theory, this observation was given by Lowry. Don't spell it wrong. Lowry. Fine. Lowry. Arrhenius gave the H+ and OH- hypothesis. Lowry gave the H+ acceptance hypothesis or theory by the basic, and this determines the basic nature of a substances. Easy, clear. And salt is acids plus base. What produces is salt. Easy, right? It's easy, sir. Now I understood what is acids, what is base, and what is salts, and who gave these concepts. History and the concepts cleared at once, sir. Easy, right? Don't ever get confused. Now, how will we identify the nature immediately? Can we observe hydrogen separating? Can we observe OH- separating? It's not that easy. It's not easy for a naked eye to observe these things. So what the scientist has done is, what our ancient Indian people has done is, they got indicators. What are indicators, sir? They got indicators. So what are indicators, sir? Indicators are substances that indicate whether a solution is acidic or basic. It indicates a substance is acidic or basic very easily. Those are called as indicators. If you see, it can be natural indicators like the litmus or lichens. It can be natural indicators or synthetic or artificial indicators. We'll study the examples. These are very important. A question is expected. Third one is olfactory. Olfactory means the nose, the smell. I'll explain the concept, smell. Third one is universal indicator. These are the types. We'll study the examples which are very important for the examination. See now. First one I told you, natural. Natural indicators. It is present naturally. We have seen the litmus paper, right? Litmus paper is obtained from lichens. Lichens, okay. Lichens are natural. From lichens, litmus paper is made. Usually, a question will be asked, are litmus paper natural or synthetic indicators? We think like litmus is a paper. Paper is manufactured in manufacturing unit or an industry. So it should be the synthetic indicator. No, it is obtained naturally from lichens. So it is natural indicator. Don't confuse. And litmus paper will be in two colors, the red and blue. Red and blue. If red turns into blue, then the substance is basic. If blue turns into red, then the substance is acid. Very easy. Acid means blue litmus turns to red. Base means red litmus turns blue. This is easy. The other natural indicator is turmeric. When acid is put into turmeric, there will be no change in color. See, it will be still yellow color. When a base is put into turmeric, it is changed into brown color. Brown color, okay? You see, you make lemon rice. You add turmeric to it. And you add lemon to it. Can you observe a change in color? It still remains yellow, right? Because what you add is lemon. That is citrus acid or citric acid. Acid is put into lemon, acid is put into turmeric, which is yellow, and which will remain yellow because it is acid. But if you put a base like magnesium, then it turns on to become brown color. This is turmeric. And lichens are biological indicators of air pollution. Air pollution, lichens indicates air pollution biologically. Next, synthetic indicators, sir. What are the examples? Two examples are very important. One is methyl orange. Two is phenolphthalein. Methyl orange and phenolphthalein. Okay? How methyl orange reacts, what color comes. This is important. This will be asked as a question. One question can be expected like, is it synthetic or natural? This will be very easy question. If they wanted to make a little bit tougher, they will keep it like the reaction. Will it turn blue? Will it turn pink? Will it turn orange? Will it turn brown? Something like that. Easy? Now, when acid is reacted with methyl orange, then it becomes red color like this. When acid is put in methyl orange, it becomes red color. When a base is put in methyl orange, it becomes yellow color. Easy? You have to remember these things. Next is phenolphthalein. When acid is put, it will become colorless. When a base is put in phenolphthalein, it will become pink. Easy? So pink color in phenolphthalein, that is base. Yellow color in methyl orange, that is base. Easy? Next. So then what is olfactory indicator, sir? Olfactory means, I told you, the nose, the smell. Olfactory is the nose. What you smell is the olfactory. Then how can we smell something and tell whether it is an acid or base? It is a foolish decision to smell the acid or base. It can affect your respiratory system, your bodily functions. So the indicator we use for olfactory are vanilla and onion and vanilla. How these reacts is, when an onion, this both reacts very similarly. Similar reaction will be there. When either of them is reacted with acid, when an onion or vanilla is put in acid, there won't be any change in smell. A onion will smell like onion, a vanilla will smell like a vanilla. For all those who are confusing what is vanilla, the ice cream which we eat is a vanilla ice cream. And what flavor we add into it is vanilla. The flavor of vanilla is obtained from a specific tropical flower, evergreen tropical flower called as vanilla. You see the brown dry leaves, that is called as vanilla flower. It will be very beautiful. You keep a vanilla dried one in a paper or somewhere, even after a year you can smell it like crazy enough. It It is very good smell and it is added for a taste and smell in vanilla ice cream. Okay, but when the onion and vanilla is reacted with base, the smell will disappear. You can't smell the vanilla, you can't smell the onion. Easy? That is how it happens. Olfactory indicators. The next one is universal indicators. Sir, what is universal indicators, sir? It is named after pH scale. What is pH, sir? pH was invented by SPL Sorensen. SPL Sorensen invented pH scale. pH ranges from 0 to 14. I'll explain this. pH ranges from 0 to 14. 0 is acidic. As the number increases, it becomes basic. 7 is usually called as, the mid number is usually called as neutral. Okay, the mid number is usually called as the neutral. Easy? Higher H plus concentration, lower pH. When the H plus concentration is more, I told you, when the H plus is more, it is called as acid. When the H plus is more, when it is acid, the pH should be lower. This is how the UPSC will ask the question. It will not ask when the pH is lower whether it is acid or basic. Everyone will answer this. They'll ask if H plus is more, then what will happen to pH? H plus is more means acidic. It is acidic means pH is lesser. Easy? See, this is how the pH scale will be there. This is how a pH scale will be there. It starts with dark red and then it will go on to become purple in nature or the blue color. Okay, when it is dark red, it is called as acidic. With the color change, it becomes basic. When the number is 0, very strong acid. When the number is 14, very strong base. Fine, 7 is neutral. I already told you. Now, the numbers can be asked and it can be asked to match with the color. 0 to 3 is red color. 11 to 14 is very strong base, it is purple color. 0 to 3 strong acid, red color. 11 to 14 is strong base, purple color. And you know the neutral one, that will be green. Green. And the remaining ones, 4 to 6, 8 to 10 or weak acid and weak bases. It will be orange or yellow and the blue. Easy? This is how it happens. And these ones, pH of common substances in our environment are to be mucked up. They might ask a sequence of arrangement in pH. They can give different substances. They might ask you to arrange from lower pH to higher pH or vice versa. Okay, so that you should be aware of the pH numbers or the sequence at least. Okay, so one of the main things being pure water. Water we drink is pure water, that is 7.4. The blood in our body is base 7.4. 7 is pure water, 7.4 is blood, that is a little base in nature. And milk, what we drink, is 6.5, a little acidic in nature. These are most important. The other things you can answer, I think. Toothpaste, baking soda, milk of magnesia, ammonia, NaOH, all these are basic. Just remember the names. Remember water basic, water acidic. You can remember the sequence as well. Okay. Next, theories of acids and bases. I already told you, this will be a recap of what I told you earlier. Easy. First one is Arrhenius theory. Second one is Lowry theory, Bronsted-Lowry theory. Third one is Lewis theory. I didn't discuss this. This is a bit complicated, not so very important for the examination. You can just remember what it is. Nothing more depth is required. I can explain it if you want it, but I don't want to complex your studying. I only wanted to make it more simpler. Okay, first is Arrhenius theory. Arrhenius theory, acid means produces H plus, base means produces OH minus. Bronsted-Lowry theory, produces H plus donor is Bronsted-Lowry. If it is H plus acceptor, base. Now the Lewis theory, which we didn't discuss, an acid will have electron pair. It will have a deficiency of electron pair. A acid will be having lesser electrons. It will have a deficiency of electrons. A base will be having extra electrons. It will have a pair of extra electrons. Lone electrons. It can be called as lone electrons. This is the symbol of electron. A base will be having a extra electron, lone electron pair. Lone electron pair. As base will be having lone electrons, extra electrons. Acid will be having deficiency in electron. So the acceptor is acid, the donor is the base. This theory was given by Lewis theory. We need not get into why it is a donor, why it is acceptor, how it is a donor, how it is an acceptor. That is not our scope to study. Our scope is this much. Okay, understood? Next is types of acid and origin. Again, this is very important. It was asked in EPFO, CAPF, SSC and many other examinations, including UPSC Civil Service Examination prelims. Okay, so this is very important. Not much to be taught in this. You have to mug up. I'll just give a brief introduction. Formic acid in ants and bee stings. The insects which sting us, they usually have formic acid. The acetic acid will have, the vinegar what we use in this, what we use for the preservation purpose, will be having acetic acid. The curd is very easy, lactic acid, you know that. Lemon and orange I already discussed, it will be having citric acid. The amla will be having ascorbic acid, ascorbic acid. The apple will be having malic acid. Spinach, tomato, the veggies, spinach and tomato will be having oxalic acid. Now the tangy flavor, what gives the tangy flavor? Usually tamarind and grapes gives the tangy flavor. Tartaric acid is present in that. Onion, this is important. Sulfenic acid is present in onion, sulfenic acid. In a rancid butter means butter which is about to spoil, rancid butter or spoiled butter. Butyric acid is gives the rancid nature for the butter. Easy, just that you have to remember these things. Which acid is present in what substances. Next is H2SO4. What is the name for H2SO4? Yes, you are right. It is called as sulfuric acid. Okay, that is called as king of acids. Why it is called king of acids, sir? Because many of the manufacturing units, manufacturing processes uses sulfuric acid. This is one of the most widely used sulfuric acid, most widely used acid, so it is called as king of acids. Next is nitric acid, HNO3. These are used in explosives like TNTs and various other explosives. So HNO3. And HCl is hydrochloric acid. This is used in gastric juice for digestion, and it also kills the harmful bacteria in our stomach. Last is, what is this? Butyric acid. It is present as antiseptic. Antiseptic agents will use this H3BO3, butyric acid. Easy. Let's move ahead. Next is strength of acids. Acids will be divided into weak acid and strong acid, as I told you. 0 to 3 pH. 0 to 3 pH, if it has, it is called as strong acid. And 4 to 7 or weak acids. You have to remember which are strong, which are weak. Hydrochloric acid, sulfuric acid, HNO3. These are strong acid. I'll tell you why it is called as strong acid, why it is called as weak acid, I'll tell you. Next is acetic acid, citric acid, lactic acid. All these are weak acid. Only exception is carbonic acid is a weak mineral acid. Why? It releases more H+. If it releases more H+ means it is called as strong acid. You know that. If it has more H+ ion concentration or it releases more H+ ions, then it is called as a strong acid. though it releases more H plus ion, it is still considered as weak mineral acid, carbonic acid. Now I will tell you by the strong, by the weak nature of acids. I'll take a whiteboard. See now. You see, we take two acids. One is HCl. What is HCl called as? Hydrochloric acid. The second one being CH3 COOH. This is called as acetic acid or acetic acid. Acetic acid or acetic acid. Okay, this is one kind. This is the other kind. Now, this is called a strong acid. This is called as weak acid. Why, sir? Why? We know this is strong and this is weak. And why it is actually strong, why it is actually weak? I'll tell you. See, it has HCl. When you mix it with water, it will completely ionize. Completely ionize means each element in that molecule will separate and each will cause an ionization. Ionization means it will get a charge. See, H is there, no? H will become H plus, HCl will become H plus and Cl minus. Completely ionized, no element left, completely ionized. How much ever HCl are produced? So many H plus are produced. All the H particles, the hydrogen particles will get a charge H plus. Now, CH3COOH is there, acetic acid. If it is dissolved, if it is ionized, what it produces is CH3COO minus and 1 H plus. Now see, this is kept as separate ion, polyatomic ion. See, many atoms are there, but it will produce only one ion, polyatomic ion. Here 1 H is produced. For such a big molecule, only 1 H is produced and the 3 H remaining remains as it is without conversion into an ion. So, this is partial ionization. Not all the atoms converts to ions. Ions means it should have a charge. It should be either positive or negative. It should be either positive or negative on its head. Then it becomes an ion. See, CH3COOH, for so many atoms, you are having only one charge, one negative charge. So, polyatomic ion. And only 1 H plus ion for such a big molecule. HCl, it is only two atoms, H and Cl, and each will get a charge. And H will multiply as it is. How many ever molecules are there, how many ever H's are present, it will still produce so many H plus ions. So it will have more concentration of H plus. It will have more concentration of H plus. So it is strong. More the concentration of H plus, it is strong. Here H plus concentration is very less. 1, 4. How many atoms? Count. 1 atom, 3 atoms, 4 atoms, 5, 6, 7. Out of 8 atoms, only 1 H plus. The concentration is 1:8. It is even lesser concentration. This is a rough estimation, 1:8. But there 1:1. 50% is H plus ion. Concentration is huge. So strong, so weak. Understood strong acid, weak acid concept? Easy. Similar is the concept for basic. If you get more OH minus, more basic concentration, if the concentration of OH minus is more, then it is strong base. When the concentration of OH minus is lesser, then it is called as weak base. Understood, right? Very easy, sir. I understood now, sir. I will not forget from now on. That is what I also expect, dost. So easy. Now, what are the properties of acids? Now see, regardless of acids or base, when it's dissolved in water, what it produces? It produces ions. Ions like OH minus, the base will produce OH minus, the acids will produce H plus. So when it has a charge, when a charge is released in water, it will have the ability to conduct electricity. Strong acid will release more ions, so more electricity. Weak acid or the weak bases will release less ions, so weak electricity. However, both acids and bases conducts electricity for sure. Okay, it conducts electricity for sure. Properties are: acids will be sour in taste. Acids will be sour in taste. Bases will be bitter in taste. Bases will be bitter. B-I-T-T-E-R. Bases will be bitter in taste. This litmus test, you know it. Conducts electricity, you know it. Aqueous selection. And acids will cause corrosion. Corrosion. Acids are corrosive in nature. It will cause corrosion. Easy? Now, reaction of acids. This is very important. Confusing. You have to mug up things. You have to remember it. If you don't remember these things, write it down. These equations in a plain paper where you have written the new words, so that you revise these equations again and again for 1,000 times before the examination. But a question is expected for sure, 100%. When acid is reacted with metal, when acid is reacted with carbonates, when acid is reacted with metal oxide, metal 1, metal oxide, carbonates. When acid is kept for neutralization. Neutralization means acids and base combine to form salts, right? That process is called as neutralization. Neutralization because acid will go, base will go, it will form a neutral, that is 7. pH 7, neutralization. Okay, this is easy, but these three you have to remember. When acid reacts with metal, what it forms is a salt plus hydrogen. Salt plus hydrogen. Now again, when acid reacts with metal oxide, now acid is reacting with metal oxide. Now what it is giving is a salt. Here H plus is giving, right? It is giving H plus, H2, right? Now here it is giving a H2. A metal will not have oxygen. Metal will not have oxygen. So in release it will give only H2. But a metal oxide will be having an oxygen. So it will release both H2 and O. That H2 and O will combine to form H2O. This is easy. When it reacts with metal oxide, salt plus water. When it reacts with metal, salt plus H2. But when it reacts with carbonate, carbonate will be having O as well as carbon. So what this oxygen does is, few of the oxygen will go to H and it will form water, and few of the oxygens will go to C and it will form carbon dioxide. So the result is H2O plus carbon dioxide. Easy? Now it is easy. Sir, you told it is very confusing, right? In a paper you are teaching so well. Now it is very easy. Now it will be easy only. When it comes in the examination law, then you'll feel like, kya saala, maine to kuch padha tha. I thought it is very easy. Now this UPSC wale, they are confusing so much. That is how it will be. UPSC, it will make your future worse if you don't concentrate. UPSC is something like, I don't have words. Ask the people who attempted prelims this year, they'll tell you, regardless of a person cleared UPSC or not cleared UPSC, ask an opinion on UPSC, they'll tell you. Okay, so the examples, you can study the examples. You need not remember all these things. These are examples for what produces hydrogen or water or hydrogen plus carbon dioxide. These are examples for that. Just that you should know if zinc is a metal or metal oxide, if copper oxide is a metal or metal oxide, if NaCO3 is carbonate or what. If you know that, your answer is done. And this thing too, you already know neutralization, you already know HCl plus NaOH will produce NaCl. I told you 2-3 times. It is easy. Now the next one, properties of bases. So you told properties of acids. Acids will taste sour. bases will taste bitter. Both acids as well as bases conducts electricity. Acids will have lesser pH, that is 0 to 7. Bases will have greater pH, that is 7 to 14. These are a few things. See, bitter test, you know this. Litmus test, you know this. OH minus ion, you know this. Electricity, you know this. Now, this is something which you should know. Distilled water does not conduct electricity due to absence of ions. See, in batteries, you observe the UPS batteries, right? The backup power batteries, which are present usually in commercial buildings and houses. Power backup batteries. We usually fill distilled water in that. Why not water? Why not normal water? Distilled water means ions will be removed from that. When ions are removed, it can't. The particles cannot carry electricity. It can't carry energy. I told you, more the electricity. When the ions are itself are removed, no electricity. That is why distilled water are used for battery backups. Distilled water does not conduct electricity due to absence of ions. This is easy. Now, the types of bases, you know that, strong and weak. Examples you can study. Sodium hydroxide, potassium hydroxide, and these are something we should also know. Weak acid, which are strong, which are weak. Okay. Why strong, why weak? More hydroxide concentration, less hydroxide concentration, that determines the strong or weak in nature. That concept you should remember, right? You remember. Then what is alkali, sir? I always thought alkali or alkyl means bases. It is something similar to base, connected to base, but not exactly base. Base is purely whether low pH or high pH, whether less OH minus oxidation or H plus oxidation related to that. Okay. But what is alkali? Alkali are water soluble bases. When a base or soluble in water, when a base is put in water, and that base, if it is soluble in water, then it is called as alkali. If it is not soluble, it is not alkali. Okay. So it is like all the alkalis are bases, but all bases are not alkalis. Confusing but easy, sir. Confusing but easy, sir. Now the reaction of bases, just like how we saw the reaction of acids. This is also easy, don't worry. But if you don't study, you will lose 2.67 marks for sure. That will determine whether you clear the examination or you don't clear the examination. See, I told you. One can be reaction with metals. The second thing will be reaction with non-metal oxides. Non-metal oxides. Reaction with metal or non-metal. Still it has oxides in it. Oxides means O, oxygen ions. Okay. When it reacts with metal, what it forms is salt plus H2. Salt plus H2. When it has water, it will become water. When it has oxides, it will become water. The H2 will become water. Examples you can study. Next, dilution of acid. What is dilution of acid, sir? Dilution of acid. See, you would have gone to chemistry labs, right? For arts who didn't go to chemistry labs? Of course, sir, you would have gone to chemistry labs in school, at least 8th standard, 9th standard, 10th standard. But if you had not gone to chemistry labs, see, there will be like a mixing. There will be a situation where you should mix a water with a base, a water with a acid. Water and acid should be mixed. For a better clarification, I'll take a whiteboard and I'll explain you clearly. See, at one side you have water. In one container or tube you have water. The other container you have acid. Now, what you will do? Will you take water and mix it with acid, or will you take acid and mix it with water? Taking acid, mix it with water means you are taking 1 ml. This is 1 liter. This is 1 liter. This will also be 1 liter. Say, both are in 1 liter containers. If you are mixing acid with water means 1 ml acid is put in water. If you are mixing water with acid means we are mixing 1 ml, 1 milliliter. 1 milliliter means 1,000th of a liter is mixed with acid. Will you do that or will you do this? That is a question now. That is called as dilution of acid. Which is correct process? The correct process is this one, sir. This is wrong. Why? The mixing of water with acid is an exothermic reaction. Exothermic reaction means release of heat. Heat will be released. Release of heat will happen. Exothermic reaction, release of heat outside. When a water is put into acid, exothermic reaction will take place. Then what happens is more amount of heat will be released by the acid that can't be neutralized by the water. Then what happens to the acid is it will splash. It will spurt into our face or skin. It will react. Then it might cause the injuries or the burns. Okay. But in this case, if a bit of acid is mixed into water, then we'll have a huge amount of water which can neutralize, which can reduce the heat of acid. So that is the right process. This is called as dilution of acid. Easy, right? Can we go ahead? Easy. If any doubts, you can comment it down. Next one, importance of pH in everyday life. Importance of pH. You can study all these things. Acid rain, you remember the acid rain, right? Acid rain means pH should be less than 5.6. This number is important. Other things you can study through the slides. Second is tooth decay. Tooth decay begins when the mouth pH is acidic, 5.5. When the mouth pH becomes less than 5.5, tooth will decay. So the pastes are manufactured in such a way so that they have more base nature. When the pastes are more basic, then what happens is it will increase the pH. It will make the tooth go towards more basic. So the pH will increase from 5.5, decay will reduce. That is the mechanism in toothpaste. Okay. Next is toothpaste is basic and neutralizes acid. This is the mechanism. Second thing, digestion. You know digestion. HCl. HCl will excess acid also. HCl is important to kill harmful bacteria. But HCl is more means it will cause indigestion also. It should be in a proper amount. And if the HCl is more, then it causes gastritis. The solution is antacid. Antacid means not an acid obtained from ants. Antacid means opposite to the acids. Opposite to the acid, that those are bases. One of the major compound which we take to neutralize the gastritis, that is the gastric problem, is milk of magnesia, MgOH2. This is also important, MgOH2, milk of magnesia. Next is bee sting. Bee sting will contain formic acid. The solution of bee sting is baking soda. Even if the ants bite, what you should apply is baking soda. It will reduce the formic acid accumulation. Easy. Next, few of the important chemical compounds. We are towards the end of the chapter. Now few of the important chemical compounds which should be studied by yourself. For those who didn't join our course, you can take a screenshot of this and study it. Make sure you keep your screen in at least 1080p, 1080 pixel, so that it is very clear. Okay. Sodium chloride, it is a rock salt or table salt. The uses of it. Sodium hydroxide, the uses. Chlor-alkali process will give the sodium chloride. Here, the brain process will give the sodium chloride. Sodium hydroxide is obtained from chlor-alkali process. These are also important. The other things, the Solvay process. Solvay process will give baking soda and washing soda. Soda is through Solvay process. So Solvay will give the soda. Chlor-alkali. Alkali means base, right? So it gives NaOH. Brine process will give NaCl. Then bleaching powder, the chemical composition. Plaster of Paris. If gypsum is heated, we'll get the plaster of Paris. The uses are also important. You can just brush up these things. Nothing to be explained from that. Key products of chlor-alkali process. I told you chlor-alkali process will give chlorine and hydrogen. Key byproducts will give hydrogen and chlorine. Chlor-alkali process is used to obtain NaOH and the byproduct will be H2 and Cl2. This is enough. You can study this. It's more theoretical in nature. You can study this. Last one being few key terms which we already studied. You know what an indicator is. You know what a pH is. Easy. pH you know. Indicator you know. You know what neutralization is. Easy. You know what alkali is. You know what alkali and base is, right? Base is the substance. Alkali is if the base can dissolve in water, then it is alkali. You know what acid rain is, right? Remember the number. If it is below 5.6, then it is acid rain. You know what brine is, right? Brine is concentrated NaCl process, NaCl solution. Concentrated sodium chloride solution is called as brine. Through that brine process, while processing the brine, that is sodium chlorine, we'll get what? Acid. Which acid? HCl, hydrochloric acid. Okay. Next, caustic soda. Caustic soda means NaOH. Now these are important. Caustic soda means NaOH. Baking soda means NaHCO3. Washing soda means Na2CO3 10H2O. Na2CO3 10H2O is washing soda. Bleaching powder, plaster of Paris, milk of magnesia. These are not very important, but this is important. These two and this is important. This is relatively okay. You should remember this. I can't help much. This should what you should mug up. There are ways to make you not mug up this, but it will take a very long time. The input or the efforts we put into this is not actually fruitful. The output is very less. Questions will be less. And if we go into depth, if you go into chemical theories, it is not much useful. So I'll stick on to what is important for the examination. That is enough. Just read the slides. It is more than enough to answer 70 to 80% of the chemistry questions, which will get you through the line, get you a rank. Enough? Okay. By this we complete the chapter of. By this we can complete the chapter of what? Acids, bases and salts. In the next chapter we'll get to atoms, molecules, moles, Avogadro numbers and so on. So okay, easy chapter, easy, right? Thank you so much. Kindly join our UpSmart IAS classes for CAPF Assistant Commandant crash course by contacting the number displaying below. Okay, what we can provide for the students who join the class are PDF of all these notes and some extra value added notes. And for paper 2, we'll be giving end-to-end notes like 40 practice essays. We'll be giving the synopsis. We'll be giving the reports, letters, and entire grammar notes also. So entire paper 2 is solved. Paper 2 is something very important. You can score somewhere between 60 to 120. If your approach is right, you can get 120. If your approach is wrong, you can get 60 also. So don't miss out on paper 2. So by joining our classes, we'll be giving the entire notes, approach, we'll be giving daily answer rating, we'll be mentoring you, we'll also do the evaluation on a daily basis. Okay. Thank you so much. This is Reddy Prakash. Let's stay connected. Kindly subscribe to our channel. Thank you.